Hi, I'm Julio Cesar de la Cruz Gurrola, and today I want to talk you through two Python scripts I built for a microservice backend system. Both of them solve a common challenge in software development, and this is how do you handle tasks that need to run repeatedly, reliably, and without breaking the rest of your application. Well, let me show you how each one works. First, we have the queue verification. The first script is called verificación colas. Its job is simple but important. Every 13 seconds, it wakes up, checks a message queue, and decides what to do with each message. The core of the script is the verificar colas function. Its job is simple but important. It starts by reading all the messages currently in the queue. If the queue is empty, it logs that and goes back to sleep. No necessary work. But if there are messages, it evaluates each one individually. Here is where the logic gets interesting. Each message has an attempt counter. If a message has failed three or more times, the system doesn't keep trying. It sends it to a dead letter queue and triggers an alert. This prevents stuck messages from blocking the entire flow. If the message is still in pending status and has exceeded the limit, it gets processed normally and hasn't exceeded the limit. This pattern is clean, predictable, and easy to extend. You can swap the simulated queue for a real broker like RabbitMQ, SQS, or Redis without changing any of the core logic. Now, in the second script, the thread pool executor, here the things take a step further. It's called thread pool executor, and it's designed for a ticket printing system in a retail context. The problem it solves is concurrency. When multiple purchases happen at the same time, you need to process order, print tickets, and handle payments simultaneously, not one at a time. The problem it solves is the thread pool executor comes in. Instead of creating a new thread for every event, which could crash the system under heavy traffic, it maintains a fixed pool of 5 worker threads that are reused efficiently. Each worker receives an event, identifies its type, orders, ticket, or payment, and calls the corresponding handler. If something goes wrong, the worker doesn't give up. Immediately, it retries up to 3 times using a linear backup strategy, meaning it waits a little longer between each attempt. At the end, the result registry class collects all results in a thread-safe way and prints a final report showing how many events succeeded, how many failed, and the average processing time. Now, to conclude, you might be asking how do these two scripts relate to each other? Well, think of them as two layers of the same system. The queue verification script is the scheduler. It runs periodically and decides which messages need attention. The thread pool executor is the engine. It processes multiple events at the same time quickly and safely. Together, they represent a solid foundation for any event-driven microservice. Reliable scheduling, controlled concurrency, automatic retries, and clear logging. Both the scripts are simple enough to be understood immediately, but structured well enough to be used in a real production environment. That balance between simplicity and robustness is exactly what good backend code should look like. Thank you for your attention.